question 1, I'll use one of the 3 double angle formulae for cos 2x. So my equation becomes 2 times 2 cos squared x minus 1 equals 7 cos x. If I expand and bring everything to the left, I've got 4 cos squared x minus 7 cos x minus 2 is equal to 0. I will factorize this and get 4 cos x plus 1 and cos x minus 2 is equal to 0. This will give me 2 solutions, cos x equals minus 1 over 4 or cos x equals to 2. Now since cos x must be between minus 1 and 1, I'm going to reject the cos x equals to 2. For the minus a quarter, the principal value is the inverse cos of minus a quarter. This will give me 104.5. So my general solution is x equals to 104.5 plus minus multiples of 360, or x equals minus 104.5 plus or minus multiples of 360. From the first one, I get 104.5 degrees. From the second one, I will get 255.5 degrees. In question 2, I have to write this equation in this format. There are 2 ways to do this. One is start with the first equation, raise both sides to the power of 10 and gradually get to the second equation, or take the second equation, take log base 10 of both sides and gradually convert to the first equation. I'll go with the second method. N equals a and b to the power of t. So log n equals log a and b to the power of t. That's log n equals log of a plus log b to the power of t. So log n equals log a plus t log of b. And if I compare coefficients, then the constant term is equal to 1.478 and the coefficient of t is 0.0646. So log a equals 1.478. A is equal to 10 to this power. A comes out to be 30 to 2 significant figures to the nearest integer as required, and then log of b equals 0.0646. So b is equal 10 to 0.0646. b comes out to be 1.16 to 3 significant figures. Finally, my equation is n equals 31.16 to the power of t. For part B, I will just substitute t with 30, and this comes out to be 2575.496 ... and then to 2 significant figures, this is 2600. In this question, I'm given a curve and I'm also given the equation. I need to find in the simplest form the derivative. Note, this is a ratio of 2 functions. I'm going to use the quotient rule that says f dash of x equals to vu dash minus uv dash over v squared. In my case, u is equal to 2x plus 3, so u dash is 2, v is 4x minus 1 to the power of a half, so v dash equals to 1 over 2 4x minus 1 to the power of minus a half times 4, which simplifies to 2 over 4x minus 1 to the half. So f dash of x equals to 2 4x minus 1 to the power of a half minus 2x plus 3 over 4x minus 1 to the half all over 4x minus 1 to the half and then squared, so it cancels out. Now to simplify, I will multiply top and bottom by 4x minus 1 to the half. So this gives me 4x minus 1 minus 2x plus 3 all over 4x minus 1 to the power of 3 over 2. And when I expand and simplify the numerator, I will get 4x minus 8 over 4x minus 1 to the power of 3 over 2. Now for part B, I need to find the range of f. Note there is a minimum point, so the range is anything above this minimum, as long as this minimum is part of my domain. And to find the minimum, I will set dy in dx equals to 0. So the numerator of the derivative 4x minus 8 is 0, which means x equals to 2. This will give me a y value of 2 times 2 plus 3 over 4 times 2 minus 1 square root of that, which is 7 over square root of 7. And if I rationalize the denominator, I get square root of 7. So the range is any y value f of x bigger than or equal to square root of 7. In question 4, I'm given this graph and the corresponding equation. Part A, I need to find f of 6. So first, let's calculate f of 6. This is equal to 21 minus 2 times the modulus of 2 minus 6, which will give me 21 minus 2 times 4. Note that 2 minus 6 is minus 4. The absolute value of that is 4, which will give me 13. And then I'll substitute this back into f and repeat the process. 21 minus 2, absolute value of 2 minus 13 equals to 21 minus 2 times positive 11, since I have the absolute value, which gives me minus 1. In part B, I need to solve the equation f of x equals to 5x. Now note for this part that the vertex of this graph has coordinates 2, 21, 2, because the value of x that makes the absolute value here 0 is 2, and once this is 0, I'm left with 21. So for part B, what I will do is take this equation and split into two equations. One of them is y equals 21 minus 2 brackets 2 minus x. I can simplify this one as y equals 2x plus 17, and the other one is y equals 21 minus, so it becomes a plus of 2 minus x. I can simplify this one as minus 2x plus 25. And note, the left one has a positive gradient, the second one has a negative gradient. So the first one with a positive gradient is this part to the left of the vertex, and the other one is to the right of the vertex. So let me write that. This one is valid for x less than or equal to 2, and the other one for x bigger than or equal to 2. Obviously, when x is 2, both of these are equal. So 2x plus 17 equals to 5x will give me an x value of 17 over 3. Now, since this equation is valid for x less than or equal to 2, this x value will be rejected. From the second one, I will get minus 2x plus 25 equals to 3x. So x equals to 25 over 7, which is the only solution of this equation. For part C, I'm given that this equation f of x equals k is a constant, has exactly 2 roots. I need to find the possible values of k. So basically, this is the point of intersection of this graph with a horizontal line. I need to have 2 points of intersection. So my horizontal line should lie somewhere in this region. Now, from the equation of the left part, I know that the y-intercept is 17, and since x is bigger than or equal to 0, it means that this point is in my domain. So to have two solutions, my k needs to be between 17 and 21. 17 being included, 21, which is the vertex, is not included. And then in part D, this graph has been transformed into the graph with equation y equals a f x minus b. Now the vertex of this new graph is 6, 3, so it has moved from 221 to 6, 3. Now that's a vertical stretch by a scale factor of a, and the horizontal translation to the right by b units. So 21 times a will give me 3. So a is 1 over 7, and 2 plus b units will give me 6. So b is 4. In part A, I will start the proof from the left-hand side, which is sine of 3x. Now I will rewrite 3x as 2x plus x, and then I will expand this as sine 2x cos x plus cos 2x times sine x. Then I will use the double angle formula for sine 2x and also for cos 2x. The one for sine 2x is 2 sine x cos x times another cos x plus, and for cos 2x I will use 1 minus 2 sine squared x times another sine x at the end. If I expand this and simplify, I will get 2 sine x cos squared x plus sine x minus 2 sine to the power of 3x. And now cos squared x, I'll need to change this one. So I have 2 sine x times 1 minus sine squared x. Everything else remains the same. So if I expand, I get 2 sine x minus 2 sine to the power of 3x plus sine x minus 2 sine to the power of 3x, which will give me 3 sine x minus 4 sine to the power of 3x, which is equal to the right hand side. Now for part B, first I will rearrange what I have proved in the first part. So I'll get 4 sine cubed x equals to 3 sine x minus sine 3x, and then I'll divide by 4. So I get 3 over 4 sine x minus 1 over 4 sine 3x. So my integral becomes 3 over 4 sine x minus 1 over 4 sine of 3x dx with the same limits. This will give me minus 3 over 4 cos x, and then the sign will become minus cos. I have minus minus plus cos of 3x over 3, so I'll have 1 over 12 with my limits. So I'm going to substitute these numbers, minus 3 over 4 times a half plus 1 over 12 times minus 1 minus 3 over 4 times 1 plus 1 over 12 times 1. And if I do the calculations, I will get 5 over 24. For part A of this question, I will set y of C1 equals to 18 and solve. So 18 equals to 5e to the x minus 1 plus 3. I'll take the 3 to the other side, subtract, and then divide by 5. So 3 equals to e to the x minus 1. Then I will take log base n of both sides, so ln of 3 equals x minus 1. So x is 1 plus ln 3. Note this is a correct answer, but not in the required form. I need this to be in the form ln of k, no plus next to the ln. So to continue this, I'll just write 1 as ln of e plus ln of 3. Let's make a note of that. Note ln of e is equal to 1. So x equals ln of 3e. In part B, I need to show that one of the solutions, one of the points of intersections is 1.134. To do so, I will first equate the two graphs. So I have 5e to the x minus 1 plus 3 equals to 10 minus x squared. I have to rearrange this to get 0 on one side. Many ways to do so. I will take everything to the left. So x squared plus 5e to the x minus 1 minus 7 is equal to 0. Now I call the left hand side as f of x. Now f of 1.1335 equals to 0.001, which is positive. F of 1.1345 is equal to minus 0.007, which is negative. Now these two values are the upper and lower values, upper and lower bounds of my roots. And then I'm going to make a comment. There is a change of sign and f of x is continuous, hence alpha equals 1.134 to 3 decimal places. Now in part C, I need to use this iterative formula with this starting value to find x2 and the value of the second root, giving answers to 6 decimal places. So x2 equals minus square root of 7 minus 5e to the minus 3 minus 1. This will give me minus 2.628388. Now I'm going to repeat this procedure until 6 decimal places are fixed. If I do this, I get beta equals minus 2.620330. In part A of this question, I need to change this expression in the form r cos x minus alpha. So cos x plus 4 sin x is equal to r cos x minus alpha, and this can be expanded as r cos x cos alpha plus r sin x sin alpha. Note here I only have one cos x. Then I'm going to compare coefficients of cos x and sin x. I have 1 cos x on the left and r cos alpha on the right. I have 4 sin x on the left, r sin alpha on the right hand side. So r sin alpha is equal to 4, r cos alpha equals to 1. I can divide this side by side, so tan alpha is 4. So alpha is the inverse tan of 4. We'll use 1.326. For r, I will just find the square root of 4 squared plus 1 squared, which comes out to be square root of 17. In part B, I am given this function. Note that this part is similar to the one above. Instead of x, I have 1 over 2t. I need to find the minimum height. H equals to 24 over 3 plus square root of 17 cos of a half t minus 1.326. The minimum value of h is obtained when the denominator is a maximum. So that's 24 over 3 plus square root of 17 times 1, because cos takes values between minus 1 and 1. This comes out to be 3.37 meters. And then in part C, I need h to be equal to 10. So 10 equals to 24, 3 plus square root of 17 cos 1 over 2t minus 1.326. If I cross multiply, I get 30 plus 10 root 17 cos of 1 over 2t minus 1.326 equals 24. If I rearrange this, I get cos of 1 over 2t minus 1.326 equals to minus 3 root 17 over 85. So 1 over 2t minus 1.326 equals to the inverse cos of this number, which comes out to be 1.71 68. And if I rearrange to get t on its own, I will get 6.09. In the first part of this question, I need to find the derivative and then find the x-coordinate of the stationary points. Note that I have a product, so u equals e to the 3x, so u dash equals 3e to the 3x, and v equals sec 2x, so v dash equals 2 sec 2x tan of 2x, so g dash of x equals to u dash v plus v dash u. Let's put in the functions. 3e to the 3x sec 2x plus 2e to the 3x sec 2x tan 2x. In part B, I need the derivative to be equal to 0. So e to the 3x sec 2x brackets 3 plus 2 tan 2x is equal to 0. So e to the 3x is 0, or sec 2x is 0, or tan 2x is equal to minus 3 over 2. Now, an exponential function can never be 0, so I'm going to reject the first one. Sec is the reciprocal of cos 2x, so it can never be equal to 0, so I'm going to reject. So I've only have one option, and that is tan 2x equals minus 3 over 2. The principal value is the inverse tan of minus 3 over 2, which is minus 0.983. So 2x equals my principal value plus multiples of pi. X is half of the principal value, that's minus 0.491, plus multiples of pi over 2. This is my general solution. Now I only have one solution within the given range, and this is x equals minus 0.491. For II, I need to find dy dx. First I will find dx dy. This is 1 over sine y times cos y, so dy in dx is equal to sine y over cos y. Now I need this in the form e to the x over a function of x. Since x equals to ln of sine y, then e to the x equals sine y, and that's my numerator. To find the denominator, I will use the identity sine squared y plus cos squared y is equal to 1. So cos y equals square root of 1 minus sine squared y, which is the square root of 1 minus e to the x squared. I can write this as square root of 1 minus e to the 2x, and that is my denominator. The reason that I have kept the positive square root here is that y is between 0 and pi over 2. That is, it is in the first quadrant, so cos y is positive. In part A of this question, I will have to do long division. X to the 4 minus x cubed minus 10x squared plus 3x minus 9 divided by x squared minus x minus 12. Now x squared into x to the power of 4 goes x squared times. I've got x to the power of 4 minus x cubed minus 12x squared. I will subtract and get 2x squared plus 3x minus 9. Then x squared into 2x squared goes 2 times. So I have 2x squared minus 2x minus 24. Again subtract, and I get the remainder of 5x plus 15. So I can write my expression as x squared plus 2 plus 5x plus 15 over x squared minus x minus 12. I can factorize both the numerator and the denominator. I will get 5x plus 3 in the numerator, x plus 3, x minus 4 in the denominator. I can cancel out the x plus 3 and I'll be left with x squared plus 2 plus 5 over x minus 4. In part B, I need to find the equation of the tangent when x equals to 2. G of x equals to the expression I found above. That's x squared plus 2 plus 5 over x minus 4. I can rewrite this as x squared plus 2 plus 5x minus 4 to the minus 1. So the derivative of this is 2x minus 5x minus 4 to the minus 2. If I want, I can write this as 2x minus 5 over x minus 4 squared. Now g of 2 is equal to 2 squared plus 2 plus 5 over 2 minus 4, which comes out to be 7 over 2. So my coordinates are 2 and 7 over 2. G dash of 2 is equal to 2 times 2 minus 5 over 2 minus 4 squared, which is 11 over 4. So my gradient is 11 over 4. So now I can write y minus y1 equals the gradient x minus x1. If I rearrange this, I get y equals 11 over 4x minus 2. To find the area in part C, I will have to integrate. So the integral of g of x dx between 0 and 2. This is equal to the integral of x squared plus 2 plus 5 over x minus 4 dx. And the integral of this is x to the power of 3 over 3 plus 2x plus 5 ln x minus 4 with modulo signs between 0 and 2. Now if I substitute these values, I get 8 over 3 plus 4 plus 5 ln 2 minus 0 plus 0 plus 5 ln 4, and this will give me 20 over 3 minus 5 ln 2. Note that I have used the fact that 5 ln 4 equals 5 ln 2 squared, which is equal to 10 ln 2.